Okay, hi. So this is my video for my assignment 3 investigation video on the battery performance test. So this is the vacation app right here that I have recently made. So for my investigations, I set out to answer this question. Does continuous GPS polling drain significantly more device resource than a single on-demand GPS fixed in VK-Track? So this is relevant because every time a user opens a add location screen, right, the GPS over here is triggered to autofill the coordinates over here. So if I press on use my location, as you can see already, it really lists out the latitude and the longitude over here. So okay, so I've implemented two variants using add edit location fragment using a single Boolean flag called this one, use continuous GPS. So if this is set to true, which means that GPS is 24/7 ongoing as long as this app is on. But if I change this to false right here, if the Boolean is changed to false, then the GPS will stop tracking the user but only track one time. So for this one, you can see in the code over here, it's written here in variant A. Sorry, variant A. Okay, so in variant A over here, this is the code that that makes the GPS intervals every 2 seconds to keep the user tracked. So let's say every 2 seconds, right, the user moves to a new location, the GPS will track the user for every 2 seconds. And that, in my opinion, will eat quite a number of battery as well. And another scenario is variant B. So variant B is over here using the current location request. This is only one time. So it only tracks the user once in a location that he prefers to be in. So this is a very convenient way for the user to save the battery on this app. So to show the proof on this works, so if I go back to my old one here to the this one, okay, if this is set to true, if I were to open my logcat first and type in battery test, all right, you can see every time the battery is eaten, right, there will be a 2 seconds log, right? They will display the location two times and for every 2 seconds, sorry. All right, so if I change this to false, okay, let's say I change this to false, and if I just refresh the app, okay, sometime first. Okay, so this is set to false already lah. So if I click on add location, and if I scroll down to use my location, I press one time only, then it will only display one time. That's all. All right, so the GPS will stop tracking the user location and it will only allow to prompt out one time. So this is one evidence to show. The other one I'm using is a profiler. So if I click on the view live elementary, and if I were to show you right now, since it's false, which means the GPS chip is not really functioning. So as you can see, let me just refresh and start my allocation again. Here's my location. Okay, so as you can see, okay, after this line, there'll be not much of a graph already, right? Not much of a CPU usage over here since it's only active for one time, right? But what if I change that to false? So if I change this to true, just stop the profiler. Uh, Actually, if I've done this test already, the difference is actually very minimal. All right, not much of a CPU usage. Why? Because I'm using an emulator. So if I'm using a phone, if I connect my Android phone to this Android Studio, then it will eat more of the CPU. Then the graph will be more the areas over here, the graph will be slightly green to yellow to red color. Okay, so if this is true right now, and if I were to run the profiler again, okay, if I were to click on add location, use my location, okay, you can see right here is starting to sometimes for every 2 seconds you'll see a spike jump right here. There you go. So there's two here, there's another one here, and sometimes it just keeps going up, but depending on the usage. But again, this is very minimal because I'm using an emulator, so that's why the GPS doesn't really eat the CPU doesn't really eat that much over here. So one more thing is that why does this difference happen? Okay, so continuous GPS, first of all, keeps the location hardware chip active at all time. So if I'm using a real device, right, this prevents the CPU from entering a low power idle state. And the radio chip in the phone remains powered, right? So according to the Android documentation, um, all right, according to Android documentation, right, high priority high accuracy forces the device to use the GPS satellite chip. So it's kind of like a sensor chip and eats a lot of CPU, hence eating the battery as well. So for this one, in my recommendations, based on the results for this new one, I suggest that the app remains this to be false. So if this is false, which means when it track the location one time, then it doesn't have to keep tracking all the time, right? So that the GPS will stop prompting, will be inactive, will be idle, right? Once it saved the location. All right. So that's all for this very simple project, for this investigation about battery. All right. Thank you so much.